Okay, so now it's time to add some object selection into our application.
Oh, yes.
This is really cool. This is where you guys are going to learn how to make your mouse active in such a way that you can go in there and select various objects.
That's right.
Very handy. But first, Joel, we need to fix our cube.
Yes.
Run the application real quick again.
All right.
Show them what it looks like.
No, I don't want to rebuild. Thank you. Go ahead and create a cube and check it out. It's kind of messed up.
Yeah.
So what we're going to do is exit out of this, go over into our cube, and
it's one little simple thing on the plus side right there.
This needs to be
732.
Awesome. 7-3. Thank you. So if I run that, and I just execute it, create a cube.
Ooh.
Fixed.
Very nice.
Awesome. So now we can start focusing on our selections.
That's right.
So we're going to create a new function here called handle selections. I'm just going to create this after our handle events in our SDL demo. So all the way down here, blah, blah, right after update navigation. So right here, right above main. So what I'm going to do here is call void handle selections. So here's where all the code is going to be. Basically, what we want to do is when we click the middle mouse button for it to actually select an item.
Okay.
So we're going to start out with a static variable that stores whether or not the button down was pressed so that we can check a mouse up, a middle mouse button up. So we'll start out with false, and if the state of the middle mouse button is set to true, we're going to set our button down equal to true.
So bottom line is if middle mouse button is down, set button down to true.
That's right. Else if button down, so middle mouse button is no longer pressed.
That means you must be coming back up.
Right. Then let's go ahead and start handling our selections for real. The first thing, though, is let's set button down to false so we don't forget. Now, basically what we're going to be doing here is setting up a new area for us to render. Basically, we're going to create a little bit of a viewport, if you will, around our mouse, and then set our render mode over to GL select, which is going to start putting names into our buffer.
Okay.
And then at the very end, we set our mode back to our regular render mode, and it's going to shoot back all the names that we pushed onto the stack. And you may be wondering, this push names thing, what is he talking about? Well, there's a GL push names, and basically, when you change the render mode over to GL select, you're going to start adding names, and whatever it renders, it's going to push those names onto a stack, and then whatever was rendered is going to be in a large stack, and we're going to get that list.
But where do those names come from?
Well, basically inside of our mesh, we're going to push names onto our stack.
Aha.
So let me go ahead and start doing this. So first we're going to need a buffer to store all of this. So we're going to create a buffer, so 512, and then create a GL int to get our viewport coordinates so that we can redefine a section for our viewport. And we can get our viewport size simply by calling GL get integer v, pass it GL viewport so we can get the size of our viewport, pass it viewport, and then we can tell OpenGL what our viewport is. Oh, and of course, our viewport, we need x, y, width, and height, so this is going to be an array of 4. And remember, this is v, so this needs to be an array. And let's define our selection buffer, and the size is going to be 512, and the buffer is what we just created. So our GL buffer, or just our buffer. Now we set our render mode over to render mode GL select. So at this point, nothing we render out to the screen is actually going to be shown onto the screen. It's going to simply render stuff and see if anything that we rendered in a specific area is set onto a name stack. So I keep mentioning this name stack. Basically, every time we run through here, we're going to have to reinitialize our names. So init names basically clears out the name stack. Now we're going to need to set our projection mode over to GL projection. We're going to actually modify our projection matrix. So let's go ahead and push it so we can pop it back later. And with it pushed, let's load its identity so we can start afresh. And what we're going to do here is do a GLU pick matrix. And what this basically does is changes our render area into a really small area around our mouse. So we're going to pass the X and Y as our current mouse position, and our Y is kind of flipped. So what we're going to do is do a viewport 3, which is the height of our viewport, minus our Y. So we're basically inverting it. And then we're going to pass the width and height of our viewport, of the area that we want to select from. And that's a very small area around our mouse, so simply 1 and 1. And then we'll pass it viewport, which we just got, which is the size of our viewport. And then we're going to reset our matrix. So let's do a GL use perspective, set our field of view over to 45 degrees. And then we're going to have our GL float and do our window width divided by our window height. So window width divided by GL float window height. And Z near and Z far is 0.1f and 500f. Same as we defined above, but we're going to need to redo this here because after our GLU pick matrix, we don't want to load the identity again. So then we need to draw our scene. However, we don't want to draw all the text information that we had as well. So we're going to modify our draw scene just a little bit. So what we're going to do right now, we don't pass anything to our draw scene. We'll pass it true or false depending on whether we're in selection mode or not. And the draw scene function will handle the drawing accordingly. So we'll pass it true in this case. And then after that, we'll reset our matrix mode over to GL projection. And then do a GL pop matrix to restore our matrix back to its original state. And then we'll set our mode back over to our GL model view so we can start modifying the GL model view. Alright, so we've gone into our select render mode. We've picked out an area. We've rendered out our scene in just that one little small area. Now what we need to do is switch our render mode back, and when we do that, it's going to send us back how many total hits we got. Basically, how many things were thrown onto our stack. So int total hits equals our GL render mode, and then we'll set it back to regular GL render. And at this point, we should have a total list inside of our buffer holding which items were actually hit. So if we actually hit something, if total hits was greater than 0, what we're going to do is loop through all our hits and find out who was the closest one to us. So we're going to create two local variables, a choose and buffer3. That's the first item in our list. And inside of our depth buffer at element 2, so element 2, element 1, 0 base, so it's the second element, holds the depth at which we are. And then we're going to loop through the rest of our hits and find out which one's the closest one to us. So for int I equals 1 to I is less than total hits, I++. And then if the buffer and I times 4, basically we have 4 elements plus 1. So basically we have 4 item chunks of data. So if this one is less than, and we'll cast this over to our depth. If this one's less than our depth, for our last one, go ahead and choose that item. So it's buffer I times 4 plus 3. You notice here the depth is stored in index 1. This one's stored in index 3. And basically it just multiplies onto that. So each element is basically a size of 4. And set it to that. And we'll set our depth equal to I times 4 plus 1. And then we keep looping until we find the closest one to us. And then what we're going to do is after we've gotten to this point, we know we have a selected item. So we're going to change our selected node over to our choose item. And basically inside of our mesh, what we're going to do is push on the pointer to that particular mesh. And I'm going to go ahead and switch over to our mesh here. And right before we draw our item, right here, I'm going to push it onto the stack. So GL push name, and I'm going to cast the name to an integer and pass it this pointer. And then back inside of my SDL demo, I'm going to cast it back over to a mesh because the push name is looking for an integer here. And then at this point, what I'm going to do is pop it afterwards. Basically, you draw and then pop it, and it checks which ones were actually sent to the buffer. So to do a GL pop name, like so. So back in my SDL demo, I'm going to reinterpret cast. So this whole C casting methodology, mesh, and do a choose. So converting our integer choose over to a mesh pointer. And at this point, what we also want to do is if the shift item is selected, we want to add items into our list. Otherwise, we want to clear the list. So we're going to do it if the shift key is not pressed, so SDLK shift is not pressed, so not keys, SDL shift. then selected items dot clear. All right. Another thing we want to do is prevent someone from selecting the same item over and over again and getting added into the selected items list. So we're going to basically do a list, a search through all of our meshes. So list mesh iterator it equals selected items dot begin. It does not equal selected items dot end. So basically just looping through all selected items to see if one already exists. In fact, let's start out by saying assume that it doesn't exist. And then if we do find it, we'll set exists equal to true. So if it equals selected node, we're going to set exists equal to true. So if it does equal true, then we don't want to add into the list. Otherwise, if it does not exist, we'll go ahead and add this into our selected items list. So pushback selected node. So with that, that should be our update selection, handle selections area. But now what we need to do is go back into our draw scene function and change around a few things so that it takes in a bool selection. And another thing I forgot to mention is at the very bottom here, if I didn't select, I clicked elsewhere, and we didn't find any items right here, then let's
clear it.
Yeah, we need to clear our items out. So selected items dot clear. And of course, at this point, we've changed our selected node, so we need to update our controls as well, so that we're starting to modify the right person. So update controls. All right. With that fixed, let's go over into our update mesh, our draw mesh, and get all of that created. Basically, if we go up to our scene here, all the way up to, alright, on our draw scene, what we need to do is say B selection, and we'll default this over to false.
Okay.
And inside of here, basically what we don't want to do is clear our buffer. So if selection equals true, if selection equals false,
yeah.
my bad. We don't want to. We do want to clear. Otherwise, we don't. And we want to reestablish our projection matrix. And then we're going to do all of this drawing code. So we are going to draw all of these meshes and so on and so forth. And at the very end, after we've done all that, simply return. So if selection equals true. Simply return out, because we don't need to draw all the text and extra information that we have at the bottom here. And finally, I keep saying finally, the end is in sight, people. In our main loop here, what we need to do is actually call our update. Otherwise, it won't actually call our handle selections, because this is kind of important. If we don't call it, well, then it won't get called. So right after our draw scene, we'll call our handle selections. So after we draw a scene, then we handle our selections. So let me go ahead and compile this. Only a few. STLK L shift, for our left shift.
That's right.
And this is supposed to be state.y. And of course, it's complaining right here about an unsigned match. Let me go ahead and change this over to GLU int. And that should be everything.
Okay.
So let's go ahead and check to see what this does.
Okay.
So let me control F5 on this. So let's see what happens. If I middle click on this, check it out. It actually selects it. And if I click elsewhere, it deselects it.
Nice.
So things are going good. I'm going to do a create cube. It selects it. So if I select the cube, I can move it around. Select this one. I can move the plane around.
Make another cube.
And let me make another cube. And shift select it. So we have multiple selections.
Very nice.
So it seems like everything is working the way we want. The final thing.
Yeah, now delete one of those cubes.
Oh, okay. I can't.
That's right. We need to add that in real quick.
This is really easy to do. But it is actually, there is a, basically something that we need to think about before doing this. And that is, if we delete a node, we need to remember that we could be a child of someone else. And we don't want to leave their children list with us still remaining if we're deleted. Because then when they go to try to actually draw us as their children, it's going to fail. So what we're going to do here is create a void delete node. Void delete node. node pointer node. So just delete a particular node. And this is going to be a recursive function that deletes all of our children. So we're going to get a list of our children. The node that passed to us are children, so get children. And then loop through all of these nodes, so node, pointer, iterator. Dot begin, and simply loop through all of our children. It does not equal children dot end, it plus plus. And then for each of our children, we'll call a delete node as well. So simply call it delete node. And then simply actually delete that node. And so we've deleted the node. Well, we've at least created one function that's going to recursively delete all of our children. But there's another thing we need to do as well. We want to delete every item that's selected, right?
Okay.
And we also want to, before we do that, make sure that all of them don't have any parents. So we're going to set each of the selected items to have a set parent null, and then we're going to go through it and call the delete node for each of those. So right on the bottom, right above keys SDLK escape, I'm going to do an if keys, and if we press the delete key, I'm going to loop through every single selected item. So do a for list mesh iterator it equals selected items dot begin. It does not equal selected items dot end it plus plus. And then basically all I want to do is get the mesh. So do a dynamic cast for our IT. Make sure that we don't have some other item selected, other type of item selected. In our case, we really only have meshes that we're dealing with, but it is still very important to check to make sure. And then we're going to call meshes set parent to null. And then we're going to do the same loop again, but this time calling the delete node for each. So copy this, paste this in, and call delete node with mesh. Let me go ahead and compile that and see if it seems to work. And finally, once we've deleted it, the thing is we want to clear all our selections. Since we've deleted all these items, and if they continue to stay left there, well, we could have a serious problem. So let's do a selected items dot clear. And go ahead and render that out. Compile it out. Keep saying render. So if I compile this and run it, let me create a cube, move it around a little bit, and try to let me create another cube. So let's select this item, press delete. Ooh, we have a simple problem. So let me go ahead and do an F5 on this and see what exactly is causing my problem here. So let me create a cube, create another cube, move it over. So if I press the delete button at this point, let me go into my call thread here. Let me see. We have our set parent. All right. Basically, what we need to do here is make sure p does not equal null at this point, because in our update navigation, let's see. Under our delete, if our mesh equals null, we need to continue. That doesn't seem right. Let me see. So we cast our mesh over, set our parent to null. Let me go back into here. So if p equals null and parent does not equal null, remove it. And parent, okay. Basically we need to do another test here that tests whether or not p is null. So if p does not equal null, and otherwise we shouldn't even be calling this.
Right.
So if I run this and go to my create cube, move this over, not so much, create another cube, select this guy, try to delete it, and now deletes it just fine. So we just needed to check to make sure we don't get the parent of a non-existent parent.
Right.
And let me just, okay, we don't have our parent. I was going to say try a parent and delete,
yeah,
but we don't have that yet. That's going to be in the next video.
That's the last thing we've got to do in this application. Very good. So with that, that is going to wrap up this video. Thanks.